We're now going to look at more reduction formulae. Let's start with the integral of sine to the n theta between 0 and pi by 2. So I'd like you to pause your video and have a go at that for yourself. You will get much more from this if you do try to do it for yourself rather than just listen to me. Well, I hope you did pause your video. This one is done as usual by integration by parts. One mistake that people make here, they usually find out fairly quickly that it doesn't work, is to try v dashed is 1 and u is sine to the n theta. The awkward thing that happens here is that v would have to be theta, and then in your next integral you've got the integral of theta sine to the n minus 1 theta cos theta, which is even nastier than what you're looking at the moment. So that is not a good idea. Instead, we need to split this up. The integral 0 to pi by 2 sine to the n minus 1 theta sine theta d theta. Now you can take u is sine to the n minus 1 theta, and that v dashed is sine theta. Once again, if you haven't managed this yet, I would like you to pause and see if you can cope with it with the hint that I've just given you. Well, did you manage it this time? Let's carry on. If that's u dashed is going to be n minus 1 sine to the n minus 2 theta times cos theta. And if v dashed is sine theta, then v is going to be minus cos theta. Putting those in, uv, that is minus cos theta sine to the n minus 1 theta, minus the integral of v, which is minus cos theta, du by d theta, which is n minus 1, times sine to the n minus 2 theta cos theta d theta. We are looking for things which only involve a power of sine. We actually have cos times cos. We've got that cos squared theta. If I want to change that into sines, I've got to write 1 minus sine squared. Limits on the first bracket are 0 to pi by 2. Cos pi by 2 is 0. Sine 0 is 0. So they have disappeared. I've then got n minus 1 integral 0 to pi by 2 sine to the n minus 2 of theta, and then I am multiplying by cos squared, which is 1 minus sine squared. Zero plus n minus 1 integral 0 to pi by 2 sine to the n minus 2 times 1 minus sine to the n minus 2 times sine squared. That's sine to the n d theta. And this we can rewrite as in is equal to n minus 1 in minus 2 minus n minus 1 in. Add n minus 1 in to each side, divide by n, and you will get that in is n minus 1 over n minus 2. So there is your reduction formula for sine. Just a little bit of care is needed when you're using this. So let's look at two examples. Let's take n equals 6, and the important thing that I'm looking at here is that n is even. I6 is going to be 5 over 6 I4. That is going to be 5 over 6. I4 is 3 over 4 I2. 5 over 6 times 3 over 4 I2 is going to be 1 over 2 I0. And I0 is the integral of 1 d theta from 0 to pi by 2, and that is just pi by 2. So this is equal to 5 over 6 times 3 over 4 times 1 over 2 times pi over 2. 3 cancels, leaving me with 5. 2 times 4 times 2 times 2 is 32 times pi. There is a slight difference if we look at what happens when n is odd. So let's look, just as an example, at n equals 5. And the thing I'm really looking at here is the fact that I'm using an odd number. I5, using the formula, is 4 over 5 I3, which is 4 over 5 times 2 over 3 I1. We can't go any further because we can't really go to the integral of I minus 1. That wouldn't fit all the algebra that we've done. We need to look at I1, is the integral from 0 to pi by 2 of sine to the 1 theta, d theta. That's equal to minus cos theta from 0 to pi by 2. That's equal to minus cos theta from 0 to pi by 2. If I put pi by 2 in, I put 0. If I put the 0 in, I get minus cos 0, I get 1. And so in this case, I've got 4 over 5 times 2 over 3, that's 8 over 15 times 1. So just a little bit of care needed. If you're going down 2 at a time from n to n minus 2, you may well have different things to look at when you're dealing with even and odd. One more example. What happens if we take the integral of tan to the n theta d theta? And I'm going to let you have a go at that for yourself. So pause the video and see if you can do that one. Well, have you managed it? How can we use integration by parts? Once again, we don't want to use v dashed is 1. That brings a theta into it. A theta times a power of tan is very nasty. What do we need to think about? We need somehow to get something in. You should be familiar with the idea that if I differentiate tan theta, I get sec squared theta, and that tan squared theta is sec squared theta minus 1. So here is In. Let's rewrite that as tan to the n minus 2 theta tan squared theta. This is just tan to the n minus 2 theta times sec squared theta minus 1. Tan to the n minus 2 theta sec squared theta minus tan to the n minus 2 theta d theta. Well, the last part of this is just minus I n minus 2. What are we going to do with the first part? And this is where you need to remember that. We now have u to the n minus 2 du by d theta. This must all have come from differentiating tan to the n minus 1. Let's write it a little bit lower. This must all have come from differentiating tan to the n minus 1 theta. If I differentiate tan to the n minus 1, I get n minus 1 tan to the n minus 2 times sec squared. So here is our reduction formula for tan to the n. We start off the normal way, and then we find that we don't actually have to do any integration.